In this video, I'm going to show you how to use the LibreText calculator to conduct a goodness of fit test. So in this problem, a report just came out stating the percentages of favorite ice cream flavors for Americans. And I won't read them all, but here is the list. An ice cream shop owner thinks that her customers are not like the rest of America, and so she samples 795 of her patrons and asks them what their favorite ice cream flavor is. And that's what we have here in this chart. So what we want to do is conduct a test that will tell us whether or not her patrons' favorite flavor of ice cream follows the same distribution as Americans' favorite flavor of ice cream. So I've started us off here. For vanilla, if 24.7% of Americans prefer vanilla, then we want to compute 24.7% of 795. And that would give us how many of her patrons we would expect to prefer vanilla if they follow the distribution that America does. And so I multiply 795 times 0.247 and I get 196.37. And so I'm going to use, when I answer this question in the table, I'm going to put 196 because I have to round to whole numbers because these are people. All right, for chocolate, I multiply 795 times the percentage of people in America that like chocolate, and that's 0.235, and I get 186.83, so I round up to 187, and so forth. The next one's going to be 75, and the penultimate one is 64. And then we're just told the rest of the people in America prefer other favorites. And so we have to figure out what percentage that is. So if I add the percents that like vanilla, chocolate, butter pecan, and strawberry together, that gives me 65.7%. So 100 minus 65.7 gives me the percentage of the other category, and that is 34.3. So here I want times 0.343, and that's approximately 272.69. So I'm going to take 273 as my expected frequency. All right. Now, as I stated before, we're using a goodness of fit test because we want to know if the distributions match. How closely does the distribution of favorite ice creams for her shop mirror that for America? So when we conduct a goodness of fit test, for the null hypothesis, the distribution of ice cream at her shop is the same as it is for Americans in general. And then the alternative hypothesis is the opposite of that, not the same as, okay? And then degrees of freedom. The degrees of freedom in a goodness of fit test are the number of categories minus 1. Now we're given vanilla, chocolate, butter pecan, strawberry, and other. That's 5 categories. Minus 1 is 4 degrees of freedom. Now you don't need that to actually use the calculator that we're going to use, but you might need it to use some other statistical calculator. So now let's jump over to the list of calculators and go down to goodness of fit, okay? And here, we're just going to enter the data values that are observed against those that were expected. So the observed data values are 191, and we have to separate these by commas, 217, 83, 50, and 254. And now we'll put in the expected values, 196, and so on. And there we go. And then hit calculate, and we'll get our test statistic. So let's scroll down here. Test statistic, chi-squared. We want 3 decimal places, so 10.179. And the p-value is going to be the area in the tail to the right of that, and the p-value to 4 decimal places is 0.0375. Our level of significance is 0.1. So in this case, our p-value, 0.0375, is less than or equal to our significance level. And the rule is when p is low, the null must go. So we reject H0. And recall, H0 was that the distribution of ice cream at her shop was the same as it is for Americans in general. And if we're rejecting that, then we can state that there is sufficient evidence to conclude that the distribution of favorite ice cream for customers at her shop is not the same as it is for Americans in general. I hope that helps.